Question 21. The reaction between carbon monoxide and nitrogen dioxide follows a two-step mechanism. What is the rate expression of this reaction? So we have been given two elementary steps, and the first step is the slowest step, hence we can say that is RDS, that is rate determining step, and the molecularity of that step is 2, so it's a bimolecular, and the rate expression will be equal to K and then the molar concentration of NO2 square, because there are two molecules involved. So let's look for the options. So A is the correct answer. Question 22. Carbon dioxide dissolves in water as shown in the equation below. What will happen if the temperature of aqueous solution is increased? This is an example of ocean acidification. Forward reaction is exothermic, hence the backward reaction will be endothermic. Okay. If we increase the temperature, equilibrium will try to decrease the temperature. In order to decrease the temperature, equilibrium will shift to the endothermic direction, which is backward in this case. So reaction will shift to the left, to the backward direction, and the hydrogen ion concentration, or H3O plus ion concentration, will decrease and the pH will increase. Let's look for the options. Now down the choices, equilibrium shift to the left. A and B is not the correct option, so that leaves us between C and D. So the hydrogen ion or H3O plus ion concentration will decrease, hence the pH will increase because there's a seesaw relationship between hydrogen ion concentration and pH. C will be the correct answer. Question 23. Which of the following statements is correct for the position of equilibrium of a reaction? Delta G naught is equal to minus RT ln K. So the first statement, it will always shift to the right when temperature increases. This statement is wrong. The direction of shift when temperature increases depends on whether the forward reaction is exothermic or endothermic. So we can't say, hence this statement is wrong. Number 2, if delta G naught is less than 0, so that means reaction is spontaneous, then K is greater than 1 and products are favored over reactants. So that statement is true, because if the value of equilibrium constant is greater than 1, so we say reaction is product favored, and delta G will be less than 0, hence reaction will be spontaneous. So statement number 2 is right. Number 3, if delta G is 0, then K is equal to 1 and the reactant and product are approximately equal. So this statement is right. When K is equal to 1, so reactant and product, they are approximately equal, and the value of delta G will be 0. So let's look for the options. We're looking for 2 and 3. C is the correct answer. Question 24. The pH of an aqueous solution Z is 5 and the pH of an aqueous solution X is 10. What is the ratio of their H3O plus concentrations? So we know H3O plus ion concentration will be equal to 10 to the power minus pH. For Z, we will have 10 to the power minus 5, and for X we will have H3O plus ion concentration will be equal to 10 to the power minus 10. So next, let's find out the ratio. So Z divided by X, so we will have Z is 10 to the power minus 5 and X is 10 to the power minus 10. So if we solve this, that will give us 5. So what does it mean? This means that H3O plus ion concentration in solution X is 5 times lower than Z. So let's look for the option. Option D is the correct answer. So H3O plus molar concentration is 1 time 10 to the power 5 times lower in X than in Z. Question 25. Using the data provided in the table, which of the conjugate bases is the strongest? Acid, after giving a proton away, becomes a conjugate base, and weak acids, they have strong conjugate base because equilibrium shift to the left. So what we're looking for here, the weakest acid. So Ka value, higher the Ka value, stronger will be the acid. So we are looking for the weakest acid from given all the options. So we're looking for the lowest value for Ka, which is the first one, HClO. So HClO, when it gives proton away, it will convert into ClO minus as a conjugate base, and that will be the strongest conjugate base from the giving option. So hence A is the correct answer. Question 26. Consider the phosphate buffer system, Na2HPO4, NaH2PO4. What is the correct when small amount of a strong base is added to a buffer? Buffer solution is a solution that resists change in pH upon addition of small amount of acid or a base. And given example is an example of acidic buffer that maintain pH less than 7. Acidic buffer consists of a weak acid and its salt with a strong base, or a weak acid and its conjugate base. So sodium ions here will act as a spectator. So let's identify which portion act as a weak acid. So H2PO4 minus will act as a weak acid. So weak acid. And then HPO4 2 minus is its conjugate base. So let's see, if we add a strong base like sodium hydroxide, so OH minus of that base will react with the weak acid H2PO4 minus, forming water H2O plus HPO4 2 minus to maintain the pH. So let's read these statements. OH minus react with sodium ion to form sodium hydroxide. No. H2PO4 minus increases. No, that will decreases. Molar concentration of HPO4 2 minus increases. That is correct. So hence C is the correct answer. Question 27. A 25 centimeter cube sample of weak base was titrated with hydrochloric acid HCl. So what we're looking for here is a half equivalence points. So the volume added is 25. Half of that will be 12.5. So which comes somewhere in between here. So if we read from here, pH will be 9 because pH at half equivalence point is equal to pKa, and pKa plus pKb is equal to 14. So pKb will be equal to 14 minus pKa, and pKa is equal to 9. So the value of pKb will be 5. Hence B is the correct answer. Question 28. In which reaction does hydrogen act as an oxidizing agent? So oxidizing agent is a species that gains electron, that accepts electrons, so itself reduces and oxidizes other species. So let's look at option A. In option A, nitrogen is 0, hydrogen is 0. So hydrogen is +1, +1, +1. So hydrogen oxidized here. That is not the right answer. Hydrogen is acting as a reducing agent, but we're looking for hydrogen acting as an oxidizing agent. So option B, sodium is 0, hydrogen is 0 on reactant side, and we have a metal hydride. So in metal hydride, hydrogen will be -1, so sodium will be +1 here. So 0 to -1. Hydrogen is acting as a oxidizing agent because it has gained electron and get reduced. B is the correct answer. Hydrogen is acting as a oxidizing agent. Question 29. A voltaic cell is constructed from half cells using metal X and Z as electrodes. What will occur when this cell produces electricity? So let's work out which half cell need to get oxidized. So the most negative value is for the second half cell, and that half cell need to get oxidized because it's a better reducing agent. So Z will oxidize into Z2 plus 2 electron. And the first half cell need to get reduced, so X2 plus will gain 2 electron and becomes X solid. So Z will act as a anode, and electron will start moving from Z towards X through the wire. So X will act as a cathode. Okay. So when Z will oxidize, so more and more Zn2 plus ions will keep piling up into this half cell. So the mass of Z electrode will start decreasing. And the mass of X will start increasing because X2 plus will gain 2 electron and start depositing on X. So let's read through these statements. A. Positive ions flow through the salt bridge to the Z half cell. No, is wrong. Is the negative ions, they need to move through the salt bridge to maintain the neutrality. So B, electrons flow from X half cell to the Z half cell now, because Z is acting as an anode, and the electron they move from anode towards cathode, because Z is more reactive, so B is wrong. C, the concentration of X2 plus ions increases. No, the concentration of X2 plus ions decreases, so hence this statement is wrong. That leaves us D as the option. So the mass of electrode Z decreases because Z get oxidized into Zn2 plus. So D is the correct answer. Question 30. Which statement is correct for a reaction in voltaic cell for both delta H naught and delta S naught are positive? Endothermic change in entropy is positive. So voltaic cell is a cell which converts chemical energy into electrical energy and is a spontaneous reaction. Let's see what's the relationship between delta G and E cell. So if delta G naught less than 0, reaction spontaneous, and E cell will be greater than 0. Okay, so delta H minus T delta S is equal to delta G. So delta H is positive, delta S is positive as well. So delta H positive plus multiply minus will give us negative. So let's read these statements. E cell will increase with increase in temperature. Yes. Increase in temperature make T delta S bigger, and delta G will be less than 0, reaction will be spontaneous, and E cell value will be bigger. Okay, so A seems the correct answer. Well, let's read statement B. E cell will decrease with increase in temperature. No, because the E cell value will increase with increase in temperature because T delta S will be bigger and delta G will be more negative. Let's read statement C. E naught cell will not change when the temperature increases. This is wrong because temperature, E cell value depends on temperature. Okay, let's read D. Delta G naught is greater than 0 for all temperatures. No. At a high temperature, in this given scenario, delta G will be less than 0. So this statement is wrong as well. Hence, A is the correct answer.